Hello everyone, myself Nishant F. from Sri Venkateswara College of Engineering, Bangalore, presenting on data processing instruction. First, we will see about data processing instruction. The data processing instruction is an ARM data processing instruction enable the program to perform arithmetical and logical operations on data values in register. ARN means Advanced Risk Machine. It performs the data processing instruction. Then all other instructions just move the data around and control the sequence of program execution. So the data processing instruction are the only instruction which modify the data values. It also modifies the values. Data processing are divided into so many things like barrel shifter, move instruction, arithmetic instruction, logical instruction, and comparison instruction, multiple instruction. First, we will see about barrier shifter. Barrier shifter is a logical circuit of shifting a word by a varying amount. It has a control input that specifies the number of bit position that is shifting by a barrier shifter. A barrier shifter is an implemented a sequence of shift multiplexer, each shifting a word of 2k bit position for a different value of k. It also it also shift from from first place to another. It first place to end place it will shift, or otherwise last place to front it will shift. Barrier shifter perform three types of shifting operations. It it is first one is circular shift and logical shift and arithmetic shift, and one more is there amount of shift. This is about barrier shifter. You can see the barrier 4 cross 4 barrier shifter for an example. First you will see I naught uh, from for shift 0. I naught is in the position of first, and in shift for 1 I1 will be shifted, I0 will be shifted to next, I3 I3 will shift to first. This is called barrier shifter. Next, most data processing instruction can be process one of the operand using a barrier shifter. If we use the S suffix on the data processing instruction, then it updates the flags in CPSR, current program status register. Next, we will go move and logical operations. Update the carrier flag C, navigate flag N, and zero flag Z. The carrier flag is set from the result of barrier shifter as the last bit shifted out. The N flag is shifted to 31 bit of 31 of the result. The Z flag is set if the result is 0. Next we will see move instruction. Move is the simple arm instruction. Simple arm instruction. Arm is the advanced risk machine. It copies n into a determination register RD. When n is a register on immediate value, the instruction is useful for setting initial value and training the data between the register. We can see the syntax for move instruction. First, we will give the instruction and the condition and RD and N. For example, I have written for 32-bit value. For move 32-bit value into a register, RD is equal to N. Next, MVN, move the not of 36. It will not take the value 32-bit value in the register. RD is not equal to N. This is about move instruction. Next, we'll discuss about arithmetic instruction. The arithmetical instruction implement additional and subtraction of 32-bit signals as an unsigned value. Syntax, you can see syntax. This also same as that instruction, condition, and RD, Rn and N. We'll take Rn for addition, so for subtraction, and some other things. ADC, add two 32-bit value for a carrier. RD is equal to Rn plus N plus carrier. Because we used carrier, that's why we are using Rn plus N plus carrier. Well, in next example, add 32-bit value in Rd is equal to Rn plus N. We are not using the carrier. RSB means reverse subtraction of two 32-bit value. Rd is equal to N minus Rn. We have reverse the equation, N minus Rn. RSC, reverse subtraction, which carries of two 32-bit value. Rd is equal to R minus Rn minus carrier flag. SCB means subtraction with carrier of two 32-bit value. Rd is equal to Rn minus N carrier flag. Subtract two 32-bit value. Rd is equal to Rn minus N. N is the result of shifting operation. The syntax of shifting operation is shown in this figure. Next, we'll discuss about logical instruction. Logical instruction performed between logical operations on two source register. We'll see the syntax. First, we'll get the instruction, condition, and RD, RN, and N. Logical means and operations like the positive, negative, division, like something. And first we will do the some examples. And logical bitwise and two 32-bit value. RD is equal to Rn and N, or logical bit value bitwise or two 32-bit value. Rd is equal to Rn by N. EOR means logical execution of two 32-bit value. Rd is equal to Rn power N. BIC is a logical bit clear. It will clear the everything. Rd is equal to Rn and N. Next, we will see about comparison instruction. This instruction compares the two instructions. The comparison instructions are used to compare or test a register with 32-bit value. They update the CPSR flag bit according to the result, but do not affect other registers. After the bit having been set, the information can then be used to change the program flow by using conditional execution. We'll see the syntax, instruction, condition, Rn and N. For compare CMN, compare navigator, flag set result is equal to Rn plus N. We will compare. Compare set a result of Rn minus N. TEQ means test for equality of 32-bit value. Flag set as result of Rn power N. Test bit of 32-bit value. Flag set as result of Rn and N. Next, we'll discuss about multiple instruction. Multiple instruction is multiply the contents of the pair of registers and depending upon the instruction, accumulate the result in which another register. The logical multiplier accumulator onto the pair of register represent 64-bit value. The final result is placed in the declination of register or a pair of register. Syntax MLA of condition S, RD, RM and RN, and for MLA, and for multiplying we use conditional RRD and RMS, RM and RS. Next we'll see some example. MLA for multiply and accumulate. MLA means multiply and accumulate. RD is equal to RMS. We should multiply RM and RS plus RN. For multiply, RD is equal to RM into RS. Conclusion: for the data processing instruction are the essential for effective data management, analysis, and machine learning. They enable organization to store, retrieve, transfer, and analyze the data effectively, learning to inform decision making and improve outcomes. Staying staying updated with the latest Advancement in the data processing is crucial for learning the data resource successfully. Overall, data processing instructions are the key to unlock the potential of data for invocation and business successful. Thank you for watching.